Hello everyone. In our last video, we created our state. And in this video, we are going to create our functions so that we can interact with this state. So we can use two different functions to communicate with the blockchain from the front end. First, we have query functions. These functions don't consume any gas. So these functions is going to retrieve data from the blockchain for us, and we are not going to alter any data on the blockchain. And then we have the update functions. With the update functions, we are actually altering the state in the blockchain, and because of that, we are paying some gas fee. Alright, so for our project, we are going to start with the query functions. First query function that we are going to create is getParticipation. With this function, we are going to get a specific participation percentage from our state. For that, first I'm going to indicate that this will be the query function. For that, I will say ICCDK. And from ICCDK, we are going to call, as you can see here, query. And let's define our function. As you can see, we have this key U64 as a parameter. And we are going to use this key U64 to retrieve some data from our participation. And as you can see, we created our participation percentage map on the previous lesson as U64 here as the key. And that's why we are calling it with a U64. And we are going to return an option, and inside the option we will be returning U64. Now we are going to interact with the participation map, and for that we are going to use the .with function. With this function, we are actually creating an encapsulated environment for us so that we can work with our thread local variable. I'm going to call participation percentage map, and I will say .with. And again, using this function, we are actually creating our little environment so that it's safe to work with this variable. And here we are going to have our closure, and this closure will have the variable p. You can call whatever you want. And what we are going to do here is that we are going to say p.borrow. As you remember, we said that once we are working with RefCells, we can actually borrow them as mutable or immutable. And that's where we are borrowing it as mutable. Now that, as you can see, we have our RefCell, but it's a really complicated looking return value. And we are going to alter this by saying .get, and this is the place where we are going to put our key. We are basically saying that I will work with the participation percentage map, and for that I'm using .with function. And in this function, I will have a closure, and the closure will be this p. And this p indicates that we are working with participation percentage map, and it's actually what is in it. Now that we said that p.borrow and .get key, which gives us the variable that we want to. So if the key is 1, then we are going to get the variable with the key 1. If it's 2, then we are going to get the variable with 2, and it goes like this. And that's it for our function. As you can see, even though it doesn't look that simple, it's actually very simple and very short to write. Again, let's look what we did. First, we said that we are going to use a query function. Then we said that we are going to have this key as a parameter because we are going to use this key to retrieve our data. Then we use participation percentage map with the .with function so that we can work with it safely. And we said that we are going to have a closure, and this p will be the value inside this participation percentage map. And we borrowed this p as immutable, and we got the variable using this key. Actually, we are going to do a very similar process for the next one. Here, instead of getParticipation, we are going to say getExam. And instead of U64, we are going to say we are going to have an exam. As you can see, we have a little problem here. And the reason is that we are still saying participation percentage map, but we should be saying exam map. So as you can see, it's a very actually repetitive and simple process. We said that we are working with exam map. And again, we have our variable. We are actually extracting our variable with this closure, and we are using p, and we are borrowing our value inside from the RefCell with this get method, and we are giving the key to retrieve the data. Now we are going to create our update functions. For our update functions, we are going to say ICCDK, and as you guessed it, we will say update. And let's call this function insertExam. First, we will have our key as usual, which will be U64, and then we will have our value, which will be an exam. We will be returning option exam. We are returning option exam here because after we use our method that I'm going to show you in a couple of minutes, what we are getting is we are getting the old value. Since we are going to insert some exam, we are going to alter the data. What we are having in return is the last value before the alteration, and that's why we have a return statement in this situation. Again, we are going to do the same thing by saying exam map.width, and as you can see, we have a pattern here. And I'm pretty sure you guessed this. We are going to use our p, and here we are going to say p dot borrow mute. And again, as we said, that we can actually borrow variables as immutable and mutable using RefCell, and that's why we were using it. And here we are actually going to borrow it as mutable because we want to alter the data in it. And then we will be saying insert key value. We are inserting this value corresponding to the given key. But if we have already some value associated with this key, then this means that we are actually updating the value. If we don't have this key, then we are adding this. If we have this key already, then we are just updating it. Now let's do the same thing for our participation. Instead of insertExam, let's say insertParticipation. It's going to be an update function. And instead of exam, we have U64 as the value. Now this should be U64. And instead of exam map, what we have is participation percentage map. And we are using with function as we are getting used to. And we want to borrow this as mutable because we want to alter the data. And we are inserting our value to the corresponding key like we did before. And instead of an exam, we are returning an U64 as the option. Now let's try this. I will say cargo build. It looks like we are okay. Now let's have a quick overview what we did in this smart contract. First, starting from our functions, we said that we have two types of functions, query functions and update functions. Query functions are just retrieving data from the blockchain, so we are not paying any gas fee for the query functions. But the update functions are actually altering some data on the blockchain, so that we need to actually give some gas fee. So it's very important optimizing the update function. We also said that we need to use this exam map.width or participation percentage map.width. Basically, the maps that we created, we need to use them inside the functions like the way we did, so that we can have this safe encapsulated environment. And we are using closures inside them to get the data out of this closure. We are using borrow or borrow mutable if we need to alter the data or not. And then we are retrieving this data using a key, and we are using this key as U64 in our both maps. So this will be the basic structure of our smart contract, where we have our struct exam. Then we are implementing this storable and bounded storable so that we can serialize and deserialize our data, and this will create our struct with the necessary functionalities. Then we create our memory manager so that we can have multiple memories instead of one memory. And these memories will be obviously virtual memories because we cannot do this in the hardware wise. Then we are going to have our maps. You don't need to have multiple maps, but in this example, we are going to have two. And we are storing this in different memory locations that we created using memory manager above. Now that we have the necessary structure, we continued with our functions like we talked before. So as we can see, it's not that complicated after we got used to it a little. Thank you very much for this video, and I will see you on the next one.